Hello. My presentation will be about halogenation of drugs, more specifically in benzene rings. So, electrophilic aromatic substitution will be the topic I'll mainly be going over, and how different halogens on benzene rings affect drugs differently. So, yes. Um, in halogenation, at least in my opinion, we usually think of an alkene and halogen. So in halogenation of alkenes, the nucleophile is the alkene, and the electrophile is in this case Br2, the Br2. Um, so the alkene would attack the Br2, giving us an intermediate in which the negatively charged bromine would then attack the intermediate and it would, restore stability in the molecule. However, on a benzene ring, this is not possible. Br2 alone isn't sufficiently electrophilic for a nucleophile attack from a benzene ring, and that's when a different type of reaction occurs called electrophilic aromatic substitution. Uh, the difference, well, there's two main differences. In the reagents, we add bromine and iron or aluminum if chlorine is to be added to a ring. But in our case, iron can be added to bromine where they react with one another, and it gives us this electrophile, which is like a almost like a iron tetrabromide, but it's actually just oh no, it is iron tetrabromide, but in the end, the actual electrophile is a positively charged bromine. The difference in the reaction here is that the benzene ring attacks the positively charged bromine, and then it creates this intermediate sigma complex where we can see as resonance stabilized. Um, and then the iron tetrabromide attacks the intermediate, restoring the aromaticity, giving us our final product, which is a halogenated benzene ring and our iron tribromide. Oh, in these reactions, the iron tribromide actually acts as a catalyst. We can see that it is in the final product, so it is not used up, it's just used during the reaction. Um, there are many cases where the bromine can be added in different areas of the ring. That usually depends on what kind of substituents are on the ring itself. And as we can see here, there's a table where, depending on whether the substituent is a electron donating group or an electron withdrawing group, whatever is to be added, in our case a halogen, the substituents are kind of, well, not kind of, but they direct where the substituent is to be added, or halogen in this case. Um, so if it's an electron donating group, it's called an activator because not only does it direct the halogen, it actually activates the ring to react faster. So there are two positions on the ring that could be possible. If we were to look at this specific group or activator, there are two possible areas. So this is the para position. It's opposite to the group. It's called para. And then there's an ortho position, which is directly adjacent to the directing group or substituent. And depending on like how strong or how much of a electron donating group a substituent is, it could actually be a strong, a moderate, or a weak activator. We can see here that an oxygen alone, or a negatively charged oxygen, is considered to be a strong activating group, or just an alkyl group. It's a pretty weak activating group since there is no, it's just a carbon chain essentially, so not much to donate there. However, there are different positions a halogen in our case can take place. If it's an electron withdrawing group, then it can take actually just one position, I apologize. And that is the meta position, which is, I guess, no, not two, but if we were to number this, it'd be in the 1, 2, 3 position. 1, 2, 3 position. A lot of the times, sterics come into play, but when it's a deactivating group, an electron withdrawing group, it is in the meta position. Another reason why these are called deactivating groups is because they genuinely deactivate the benzene ring, causing for a slower reaction. So in our case, they're actually activating groups on the drug I will be talking about. So the drug that I will be talking about is pheneramin. It is a commonly used drug for allergies and colds. Again, more commonly used for allergies. And not only just in pheneramin, but there are many drugs where different halogens are used to modify not only the structure of drugs, but like the type of I apologize, properties of the drug. So in pheneramin, if we were to before that, we can see that this is an R group, and an R group is an activating group which takes a para or ortho position, but the para position is usually, well, not usually, but most of the time it's actually it's the majority of the product over the ortho position due to sterics. This is the more stable product. So when we halogenate pheneramin and we add a chlorine to the mix, it actually keeps some of the properties from pheneramin, but it actually makes the drug 10 times more potent. So it still uses the same properties. The only difference is that the drug is 10 times more potent, which is pretty cool. Before this project, I had no idea this was a possibility. And what's even crazier than chlorpheneramin is bromepheneramin. We can see here that a bromine is added to the para position of this R group. Again, in this case, bromine and iron were most likely the main ingredients, you could say, or yes. And in this case, the main ingredients were probably chlorine and aluminum. That is usually the case when you want to add a chlorine atom. However, back to the drugs. Brompheniramine actually also keeps the same properties of pheneramin. The big difference now is that it's not only 10 times more potent, but its effects act twice as long as chlorpheniramine. I apologize, as pheneramin. So we can see that in the pharmaceutical world, the modification of drugs using halogens can be a big deal because, just with this drug alone, we can see how much it can change just by adding an atom to it, or halogen, I apologize. And yeah, hopefully we can continue advancing on halogenating more drugs and see the type of effects it has. There are many more drugs that can be talked about, but I found these to be at least the more common drug, pretty interesting. So thank you, and yep, that is my presentation.